Hi guys, welcome back to VPN part 5. So we left off in part 4 where we configured both R1 and R3's, if you like, phase 1 tunnel and phase 2 tunnels. We're now ready to check and verify. We're at part 3 to verify the IPSec VPN. Now before I send any traffic, guys, I just want to show you some commands that we can use to verify that at the moment there is no phase 1 or phase 2 tunnels established. So what I'm going to do is I'm going to go into our enable mode and I'm going to say show crypto IPSec SA. And what this is basically saying is show me if there's any phase 1 security associations. In other words, show me if there's any phase 1 tunnels established between my two routers. And in this case, you can see, guys, I'm getting a very much blank output. There's nothing here. Also, what I can do is I can use another command, guys. I can basically say, hey, let me see if there's a show crypto IPSec, basically security association. And what this is saying is, tell me if there's information about the IPSec phase 2 tunnels. Now, you might imagine, if we don't have a phase 1 tunnel, how can we have a phase 2? So in order for phase 2 to come up, it's reliant on phase 1. So what we're going to see is, we're not going to have any information in here. In other words, there's not going to be any data packets encrypted and so forth. So let's press enter on that. And let's just have a look at what it's showing here. It's showing here, this is for my phase 2. It's going from this 10 network over to the 30 network. We can see basically the current peer address. Oh, hold on guys. This looks like a little problem here in this case. Can you see there? It's showing my current peer. Okay, that doesn't look good. So that might need to be fixed. So what I'm going to do, folks, is I'm just going to verify just before I go and have a look at basically R3 for a moment, because again, it's not going to come up until I do this. Let's just go show run for a moment. When I go show run, SEP here. Okay, so that looks okay. That looks okay. That looks good. Looks good. Looks good. Okay, let me just double check something here, guys. If I go back to R1 for a moment, let me just have a look at the show run here. Let's go show run, because I think we might have made it, maybe you spotted this already, we might have made a little boo-boo earlier. Oh, look at this, guys, look at this. Okay, look at my set peer. As you can see here, folks, that's not good. Can you see that? In my VPN map, it's basically showing this peer that's not actually a valid peer. So what I might do is, before I go any further, I might fix that problem. So again, if you remember, let's bring up our Word document from earlier on for a moment. Let's bring that up for a second. Let's just grab that up. So you might remember how we configured that section. Okay, you might remember that back here in router 1, I basically set the peer. Can you remember this? This was in the transform set. So can you see here? So I made a little boo-boo in that case. So what I'm going to do, folks, is I'm going to go back to here. So I'm going to go back to conft. I'm going to go back to my crypto map. So let's go back in here. So back to crypto map, VPN-map. Okay, in this case, go back into the correct 10 and my IPSec. Okay, so once I go back in here, what I'm going to type now is I'm going to say no set. Well, actually, what can be easier here, guys, is I can go no, and then what I'm going to do is I'm just going to copy that line here, copy, and then paste this guy. Okay, to take that out. Press enter, because I know that wasn't the correct peer. I'm going to go exit again, guys. I'm going to get rid of that Word document just to show we're finished with that for the moment. Okay, and what I'm going to do is I'm going to use that command again, and so this was a good step to verify, guys. I'm going to go exit again, and then I'm going to use that command again to show. So again, what was that show command? It was show crypto IPSec SA, and I'm just going to verify. This time, oh look guys, it's still coming up for some reason. It's still showing that. Again, well let's just double check, guys, that it is definitely removed in our running config. Show run. Let's have a quick look. It's gone from there, guys. So maybe it's just cached or it's basically just seen, because again, all of the configuration, as I can see here, guys, the peer has been set. I don't see any other configuration now relating to that 102. So let's hope that basically that's just a cached basically account. So let's just try, let's give it a go, guys, to bring up this basically tunnel. So let's do it. So what we're going to need to do, guys, is we're going to need to do an actual test. So how best to do this? What we could do, guys, is we could actually basically do a ping test. So let's ping our friends. So that was our trace route earlier when we basically hadn't got any VPN tunnel up. So let's go ping, and let's ping our friend 192.168.30.3 in this case. And let's just see. Now again, the first couple could fail here, guys. So that won't worry me. And that's okay, because if it's going successfully over our VPN, it may time out. Brilliant stuff, guys. So that's even better. So what we saw there is we lost a couple of our first pings, but then what you saw was we got reply traffic then back. Now, what that could have been, guys, was a little bit of a time delay for the actual tunnels, tunnel 1, the phase 1, and the phase 2 to come up. Now, what we can do, guys, is we can go back to our R1 for a moment, and let's run our let's just hit the up arrow for a moment. Let's hit the first to see. Brilliant stuff. Look at this, guys. This looks fantastic. We can see basically that our destination is going over here from our source. So we can see that this is now active. So this is our phase 1 tunnel, our IPSec phase 1 tunnel. And then let's do our other command that we had earlier, guys. So our IPSec, our phase 2 tunnel. And in this case, guys, have a look at this. So indeed now our current peer, we took that out. So again, it's now seeing the correct peer. And have a look at this, guys. Look at that. Sorry, guys. I'm getting excited here just seeing this. And I've done this many, many times before. But we're seeing now packets being encapsulated, 3, and packets being encrypted. And look at this, guys. We're also seeing the packets being decrypted. So again, our packets going over, and then basically packets coming back are being encrypted and decrypted. So how can we prove this even further, guys? So what we could actually do to see this, guys, to see it in action, and this is what I love to do, and I really stress that you try this out as well. I'm going to go into simulation mode for a moment, guys, and what I'm going to do is I'm going to ping from PCA over to PCC, and I want you to watch this with me. So I'm just going to go press play to go from one device to the next, but I want to pause here for a moment, and I want to look at the traffic. So you can see in here is our normal traffic. So from here, if I just move this down, what I can see here, guys, is coming inbound into this interface, I can see a regular run-of-the-mill IP datagram. So again, a packet. I can see it's going from the source IP of 192.168.10.3 PCA to the destination IP address of 192.168.30.3. Who is that? That's our PCC. So what we can do, guys, is we'll be able to see now. Have a look at this. I want you to look at this very carefully. On the outbound, what it's going to send now is going to be something different. Just to show you just one last thing. Also, you might say, what's the traffic that it's carrying? It's carrying this ICMP, a ping message. So what can we see from the outbound message? Have a look at this now, guys. We'll see that first of all, it'll show the HDLC. It's going out over this serial link. But here's something really important now, guys. Look what's happened. Our router now has put a new encapsulated header or a new packet in front. And you'll see that basically what's included now is it's coming from the source of 10.10.10.2. This is the interface here. And look where it's going to, guys. It's going to a destination of 10.20.20.2. Who's that? It's forming a tunnel between this point here, guys, and this point here. So although the traffic is going up through R2, R2 is only seeing the traffic being from the source of this interface to the destination of this interface, okay? And you might say, well, where's the rest? Where's the ping message? Well, here we go, guys. What actually, and this, I apologize, guys, because this is so exciting. What's inside of this encapsulated payload is what's called this encapsulated security payload header, which is basically encrypted traffic. So our encrypted traffic is our original IP packet, okay, going from our PCA over to PCC, and our ICMP message. But from R2's perspective, they can't see any of this information. This is all encrypted. So this will go across now, guys. This will leave the router. It will go across here. Which packet will this see? It will see the packet. Basically, let's look at it. It will see just this information. Where are you going? Where's it coming from? And where are you going to? So it'll make a routing decision based on the destination of 10.20.20.2. So it will send it down here. It will not be able to see this information here. So if they were trying to do a man in the middle, they were trying to manipulate the traffic, they wouldn't be able to see this. This is completely encrypted traffic. Once it gets to the far router, what's R3 going to do? It's going to rip off that basically IP. It's going to see this first. It's going to rip off that and it's going to decrypt all of this information here. How is it going to be able to decrypt the information? Because it has the key that it agreed between R1 and R3, that VPN key. And again, using the secure tunnel, setting up the encryption and so forth and agreeing the keys, it will basically be able to decrypt the information. What will happen once it basically does that decryption? Let's pull that back out. Once it does the decryption, what will it be left with to send to PC3? It will have just the original IP packet. So here it is, guys. We've got just the IP packet now going from, it looks like it's come from 192.168.10.3, which again, who was that? That was PCA. Going to the final destination of 30. So from PCC's perspective, it just thinks, it just came from my friend of 10.3. Again, that will go to the PC. PCC will receive it and it will send back a reply, obviously. It's a ping message. And then what's going to happen? Again, R3 on its side is going to go, you're coming from 30. You're going to a network of 10. I need to encrypt you to go back. So again, remember, basically, again, think about it. Again, normal IP packet coming in. What's it going to have to do with that IP packet? It's going to need to put a new header on it, encapsulate this, and basically encrypt all of this traffic again. So that again, R2, if it's looking at the traffic on the way back, we can't give the game away. We want to make sure that it's still encrypted. And back it comes to basically our PCA, and we can see we've got successful encrypted traffic going over our wire. So that's it, guys. One last thing I want to show you though, guys. Remember, do you remember before we did a trace route? Can you see the trace route that we did before? There was 4 hops, wasn't there? Between PCA and PCC. Let's do that trace route again. If we do a trace route back to our friend, have a look at this, guys. What we'll see is that there's now, from the perspective of PCA, what we're seeing here is 3 hops. Notice we're not seeing the hop in the middle here. Okay, what we're seeing is we're seeing the first hop going to the first router, but then the next hop is going out, guys. You'll see the next hop from R1 is going across to R3. It's like this logical tunnel that's going across here. Even though there's a router in the path, it's going through, obviously, and we know that the traffic is passing through R2, but from the perspective now of this trace route, it's creating a logical tunnel from source to destination. And that's why we're not seeing, if you like, this extra hop going from here to here to here to here. Where obviously the traffic is still going this way, guys, but we can see now our trace route, we can see that it's actually creating this tunnel, and our traffic, all of our traffic is getting encrypted going across this tunnel. If, for example, we send traffic from PCA up to PCB, guys, again, that wouldn't get encrypted. So for example, if I send traffic from here over to here, again, we might see, let's just make sure that this traffic, you can see it failed the first time. We should have connectivity, it should work. The ARP didn't work. If we show the simulation tool very quickly, guys, going from, let's delete that, let's just show that. Again, that isn't interesting traffic. So for example, when it gets to this router here, notice what it won't do is it's not going to encrypt all the traffic. Look at the traffic at the moment, guys. So again, look at the traffic that leaves. There's no extra header. There's no encapsulating security payload being added on here. Why not? Because remember, going from the 192.168.10 network to the 192.168.20 network, we didn't set that up to be encrypted traffic. Only between our site 1 and our site 3 is our encrypted traffic. So I hope from these videos, guys, you get a great insight into the power of virtual private networks, and you can see the benefit it brings towards with regards to privacy. You can see that it obviously mitigates the man-in-the-middle attack. It mitigates, for example, someone changing our information or someone being able to see our traffic. So we're getting confidentiality. We're getting the benefit of integrity so that we know that none of our traffic is being modified in the middle. And also we know from setting up our secure tunnels, we know who the peer is. So it gives us our authentication. Okay, thank you very much for joining me on these VPN videos. I hope to see you soon, and thanks for viewing.